In the middle of the desert, where temperatures can rise above 50 degrees Celsius and powerful winds sweep across endless sand, a dream was born. A dream so ambitious that many engineers around the world believed it could never become reality. Today, that dream stands taller than any structure ever built by human hands, rising 828 meters into the sky, visible from nearly 100 kilometers away. The Burj Khalifa is not just a skyscraper. It is a symbol of ambition, engineering, wealth, vision, and human determination. But behind the shining glass exterior and world records lies a story filled with risks, failures, sleepless nights, dangerous challenges, and the efforts of thousands of workers who push the limits of modern construction. This is the complete story of how the world's tallest building was imagined, designed, engineered, and built against all odds. To understand the Burj Khalifa, we first need to travel back to the early 2000s. Dubai was growing at an unbelievable speed. Massive developments were transforming the city from a regional trading hub into a global destination. The leadership of Dubai wanted something that would permanently place the city on the world map. They did not want just another skyscraper. They wanted an icon, a structure so extraordinary that people across the world would instantly associate it with Dubai. At the center of this vision was Mohammed Alabar, the chairman of Emaar Properties. His company was developing a gigantic urban project called Downtown Dubai. The project needed a centerpiece, something that would define the skyline for generations. The idea was simple in theory, but almost impossible in practice. Build the tallest structure ever created by humanity. Once the decision was made, Emaar launched a competition among some of the world's most respected architectural firms. The winning design came from the Chicago-based firm Skidmore, Owings & Merrill, often called SOM. Leading the architectural team was Adrian Smith, a man who had already spent decades designing skyscrapers. But even for him, this project was unlike anything he had ever attempted. Smith understood that creating the tallest building in the world was not simply about adding more floors. Every extra meter introduced new engineering problems. Wind forces increased dramatically. Structural stability became more difficult. Elevators had to travel unprecedented distances. Water had to be pumped hundreds of meters into the air. Even simple tasks like cooling the building became enormous engineering challenges. Adrian Smith began searching for inspiration that reflected both modern engineering and regional culture. Eventually, he found it in the Hymenocallis flower, a desert flower common in the region. The building's footprint was designed in a Y-shaped pattern inspired by the flower's geometry. This shape was not chosen only for beauty. It also provided crucial structural advantages. The three wings extended outward from a reinforced central core, helping distribute the immense forces acting on the tower. What appeared to be an elegant architectural design was actually one of the most important engineering decisions in the entire project. But designing the world's tallest tower required more than architecture. It demanded revolutionary structural engineering. This responsibility fell to William F. Baker, the lead structural engineer. Baker knew that conventional skyscraper designs would not survive at such extreme heights. Wind would become the building's greatest enemy. At 828 meters, the tower would face powerful vortex forces, capable of causing dangerous oscillations. Engineers spent countless hours performing wind tunnel tests. Scale models were examined repeatedly. Different shapes were tested. Every modification aimed to confuse the wind and prevent it from generating destructive vibrations. Solution became one of the most famous engineering innovations in modern construction, the buttressed core system. Instead of relying on a traditional steel frame, the Burj Khalifa would use a massive reinforced concrete central core supported by three wings. Each wing strengthened the others. Together, they created a structure capable of resisting enormous wind loads. The tower shape also changes as it rises. The setbacks spiral upward in an irregular pattern, preventing the wind from organizing into predictable vortex formations. In simple terms, The building was designed to confuse the wind itself. Construction officially began in January 2004. Before a single floor could rise above the ground, engineers faced another major challenge. The desert soil beneath Dubai was not ideal for supporting the world's tallest structure. Engineers had to create an incredibly strong foundation. Massive piles were drilled more than 50 meters into the ground. In total, 192 reinforced concrete piles were installed. Above them sat a gigantic concrete mat foundation nearly 4 meters thick. More than 45,000 cubic meters of concrete and over 110,000 tons of material went into the foundation alone. Everything had to be perfect, because any error at ground level would be magnified hundreds of meters above. As construction accelerated, thousands of workers arrived from countries across South Asia, including India, Pakistan, Bangladesh, Nepal, and Sri Lanka. At peak periods, more than 12,000 workers and contractors were involved in various stages of construction. Across the entire project, construction required approximately 22 million man-hours. Every day, workers operated under extreme desert conditions. Temperatures frequently became dangerous. Work schedules were carefully managed to reduce heat exposure. Giant floodlights illuminated the site at night as construction continued around the clock. While the completed tower would become a symbol of luxury, its creation depended upon the labor of thousands of people, performing physically demanding work hundreds of meters above the ground. As the tower climbed higher, new challenges emerged almost weekly. One of the biggest involved concrete itself. Normally, concrete is poured at ground level or relatively low heights. Burj Khalifa required engineers to pump concrete farther upward than ever before. The pressure inside the pumping systems became enormous. Engineers developed specially designed high-performance concrete capable of maintaining its properties despite the intense heat and long pumping distances. Some pours were conducted during the night to prevent extreme daytime temperatures from affecting the material. Eventually, concrete was successfully pumped to heights exceeding 600 meters, setting world records in the process. Then there were the cranes. Building the world's tallest structure required some of the most advanced construction machinery ever assembled. Giant tower cranes climbed alongside the building as it rose. These machines had to lift steel, concrete, glass panels, equipment, and workers hundreds of meters into the sky. At extreme heights, wind became a constant threat. Even moderate gusts could stop lifting operations entirely. Construction schedules often depended on weather conditions. A single windy day could delay critical activities across multiple floors. The exterior of Burj Khalifa presented another massive challenge. The tower required more than 28,000 glass panels, along with aluminum and stainless steel cladding. These materials had to withstand intense sunlight, sandstorms, temperature fluctuations, and high winds. Installation teams worked at astonishing heights. The facade gradually wrapped around the structure as it climbed skyward. At peak productivity, installation crews were attaching up to 175 panels per day. Every panel had to fit precisely, because even minor errors could create significant problems across the enormous surface area. As construction progressed, the tower began attracting global attention. Nobody outside the project knew its final height. Emaar intentionally kept the exact number secret. This secrecy generated worldwide speculation. Engineers continued pushing higher, while competitors around the world wondered how tall the tower would eventually become. Some believed it would exceed 700 meters. Others guessed 800 meters. Very few understood just how ambitious the final target really was. Then came one of the most difficult periods in the project's history. In 2008, the global financial crisis shook economies worldwide. Dubai's property market suffered significant pressure. Major developments slowed. Questions emerged regarding whether the tower would be completed on schedule. Funding concerns created uncertainty throughout the construction industry. Yet, despite the economic turbulence, work continued. the tower had already become too important to abandon. Financial support and strategic decisions ensured the project survived one of the most challenging economic periods of the modern era. By 2009, the tower dominated the Dubai skyline. The final stages focused on completing the upper structure and the enormous steel spire. Interestingly, much of the spire was assembled inside the building before being carefully lifted into position. This operation required extraordinary precision. Hundreds of meters above the ground, even small errors could have major consequences. Engineers and construction teams coordinated every movement carefully. When the spire finally reached its position, Burj Khalifa secured its place as the tallest structure ever built by humanity. On January 4th, 2010, the tower officially opened. During the ceremony, an unexpected announcement surprised many observers. The building, previously known as Burj Dubai, was renamed Burj Khalifa in honor of Sheikh Khalifa bin Zayed Al Nahyan, the ruler of Abu Dhabi and president of the United Arab Emirates. The name change reflected the close relationship between Dubai and Abu Dhabi during a period of economic challenges. The numbers behind Burj Khalifa remain astonishing even today. The tower stands 828 meters tall and contains 163 occupied floors. More than 330,000 cubic meters of concrete were used. Nearly 39,000 tons of steel reinforcements strengthened the structure. The aluminum used in the exterior equals the weight of several large passenger aircraft. The tower contains residences, offices, restaurants, observation decks, luxury amenities, and the famous Armani Hotel. Its elevators travel extraordinary distances at high speeds, while complex mechanical systems manage water, electricity, cooling, and safety operations throughout the structure. Every generation creates monuments that define its capabilities. Ancient civilizations built pyramids. Medieval societies constructed cathedrals. Industrial nations created bridges and skyscrapers. Burj Khalifa became the modern world's declaration that engineering boundaries still exist only to be challenged. Thousands of workers, hundreds of engineers, architects, designers, technicians, technologists, and specialists combined their knowledge to create something many experts once considered impossible. Even today, more than a decade after its completion, Burj Khalifa remains unmatched. New projects continue attempting to surpass its height, yet the tower still dominates the skyline and captures global imagination. Tourists stare upward from its base, struggling to comprehend its scale. Engineers study its design. Architects admire its elegance. And around the world, Burj Khalifa continues to symbolize what happens when vision, technology, money, and determination come together in pursuit of a single extraordinary goal. Because in the end, the story of Burj Khalifa is not really about concrete, steel, or glass. It is about human ambition. It is the story of a city that wanted the world to look its way, a team of designers who refused to accept limits, thousands of workers who transformed drawings into reality, and a tower that rose from the desert to become one of the greatest engineering achievements in human history.